Have you ever wondered how our ancestors went from picking up rocks to forging mighty swords and building incredible structures? It all comes down to one crucial element: iron. But how did they figure out how to melt a metal that requires scorching hot temperatures, well over 1500 degrees Celsius? It's a story of ingenuity, trial and error, that literally shaped our world. Let's travel back in time, way before modern factories. Early humans were familiar with iron, but mostly from meteorites. This heavenly metal was rare and precious, often used for jewelry or ceremonial daggers. It was already solid metal, so they could hammer it into shape. But the real game changer was figuring out how to get iron from the reddish-brown rocks all around them, known as iron ore. The first breakthrough probably happened by accident. Imagine an ancient campfire, built inside a ring of these iron-rich rocks. With enough fuel and a strong wind, the fire could get surprisingly hot. After the fire died down, someone might have noticed small, spongy lumps of a new material mixed in with the ash. This was bloom iron. The intense heat had caused a chemical reaction, separating the iron from the oxygen in the ore, but it wasn't hot enough to melt it into a liquid. This led to the invention of the bloomery. It was essentially a simple furnace, often a clay or stone chimney-like structure. People would layer charcoal and crushed iron ore inside, and then force air into the bottom to make the fire burn hotter. You can think of it like using a giant straw to blow on a fire. They used bellows, which are like manual air pumps, to blast air into the furnace for hours. This process was incredibly labor-intensive. Inside the bloomery, the carbon in the charcoal bonded with the oxygen in the iron ore, releasing the iron. But again, it didn't fully melt. Instead, it formed a porous, spongy mass called a bloom, mixed with impurities called slag. After a long, hot day of tending the furnace, the smiths would break open the bloomery, pull out this glowing hot bloom, and immediately start hammering it. The hammering was crucial for two reasons. First, it squeezed out the molten slag and other impurities. You'd see sparks flying everywhere as the liquid rock was expelled. Second, it compacted the iron particles together, turning the spongy mass into a solid, usable bar of wrought iron. This wrought iron could then be reheated and hammered into tools, weapons, and anything else they needed. This was the dominant method for iron production for thousands of years, from the Iron Age all the way through the medieval period. So, when did we actually start melting iron into a liquid? This required even higher temperatures, and the innovation that made it possible was the blast furnace. Developed in China around the 5th century BC, and later appearing in Europe during the Middle Ages. The blast furnace was much larger than a bloomery and could operate continuously, using water wheels to power massive bellows. These furnaces could achieve the extreme temperatures needed to fully melt the iron. The molten iron, now called pig iron, would collect at the bottom of the furnace. It was then tapped and poured into molds, often simple trenches in sand, that looked a bit like a sow suckling piglets, which is where the name pig iron comes from. This liquid cast iron was revolutionary. It could be poured into complex shapes, making it possible to mass-produce items like cannons, pots, and later, parts for steam engines during the Industrial Revolution. While cast iron is brittle, it could also be further refined to create steel, a much stronger and more versatile metal. From a chance discovery in a campfire to colossal blast furnaces, the journey of melting iron is a testament to human curiosity and perseverance. It's a process that fueled empires, armed armies, and built the very foundations of the modern world we live in today. Pretty amazing what you can do with a bit of rock and a really, really hot fire. Thanks for watching. If you enjoyed this trip back in time, don't forget to like this video and subscribe for more stories about how things are made. See you next time.